So before we kick off and we talk about building data pipelines, a few words about me. My name is Marco, nice to meet you. My background is software engineering. I've been a developer for 7 or 8 years before kind of going back to school and getting my PhD in information retrieval. So today I like to build search applications and, in general, natural language processing applications. And I try to kind of merge the best of both sides, the engineering and the research side. In terms of stuff I'm working on right now, I'm wrapping up my first book on data mining for social media in Python, so should be relevant for the PyData crowd, and it will be out over the summer. So the starting point of this talk, I have to say initially when I was writing the proposal, I was thinking about an introduction to Luigi, which is one of the tools I'm going to mention. But then I took a step back, kind of trying to look at the bigger picture. Things got a bit on the philosophical side. So the starting point is R&D is not engineering. And I think we can all agree on this. So of course, I'm using R&D as a kind of a catch-all terms for academic research, applied research, data science, and data sciences stuff. I just want to check with you how many in the audience are software engineers, software developers? A few, yeah. And who is on the R&D or academic research side? Okay. So decent split. My point is the good results of R&D, when they go in production, they are definitely high value. So how can we ease the transition from R&D to production? A little bit of wisdom from Twitter. If we apply the 80-20 rule to our industry, 80% of the time spent cleaning data and the remaining 20% complaining about the need of preparing data. It's not far from reality. And the take-home message from this is really, I've been talking to a lot of people in the industry, and whether they have big data or not doesn't really matter because they all have big problems with data. So what I'm trying to say here is data preparation, data cleaning, data quality, data governance, whatever you call it, is really still a very important point here. So it's where most of your effort are going to be spent. Now, if we take a traditional database textbook and we look at the data warehousing terminology, we find ETL as a classic way to represent basically everything that happens before we can do our smart analytics. So ETL for extract, transform, and load. It's never so simple, so it's never so linear. Usually we have many components in the ETL side. We need to extract data from many heterogeneous sources. We need to clean data, deduplication, missing values, all these sort of problems. Then we might want to apply some data augmentation, data tagging, whatever you call it, and then join at the end multiple data sets. So potentially this ETL box in the middle can get really complicated. And this is everything that happens before we can run our machine learning application or data analytics in the broader sense. If we build data pipelines, we might as well build a good data pipeline. And in my opinion, there are two key points to keep in mind. So a good data pipeline is something that is easy to replicate. So we can share it with colleagues and we can replicate experiments. So replicability in science, generally speaking, is a good idea. And also, a good data pipeline is something that is easy to bring to production, so easy to productize. So the question is, how can we do that? So keeping this in mind, replicability and easy to productize, if we move towards good data pipelines, what do we need to do? A few kind of real-life experiences. Data transformation keep your data as a suggestion. Don't override your data. You should always be able to rerun the pipeline from the beginning. That's about data sanity in general, but more specifically about your own sanity when you try to replicate experiments. If we follow design of Python, simple is better than complex. It's better to start simple and add complexity later. In particular, at some point, we're going to need to break down the pipeline into individual components. And if we're talking about Python, we can break it down into individual packages, so applying the setup.py setup tools kind of a library, and rather than having a big data pipeline, break it into smaller components. And one more suggestion, as soon as possible, try to get an end-to-end test of your pipeline. So the components of your pipeline should work well in isolation, but they should work well as a pipeline. So end-to-end test as soon as possible will kind of give you, we kind of raise the problems if they are there. You shouldn't forget about testing the components in isolation anyway. So unit testing is still very important. Now, the process of building pipelines, I've seen master students, PhD students, and even more senior people going through the same kind of pattern and the same kind of mistakes. So you start with a script, and then you hack something together, and then you have a bunch of scripts that individually they don't really make sense. So you have what they call a script soup. And then in order to try to make some sense of this big soup, you maybe write a kind of a master script to run everything. And what you end up with is really a sort of a hacky, homemade solution where you reinvent the wheel, and things are still flaky and difficult to share and difficult to rerun. So what we mentioned before about replicability and going to production is really not there yet. In terms of don't reinventing the wheel, there are many tools out there to manage pipelines, complex pipelines, and I'm going to mention one in a moment. Before going there, I just want to talk a bit more about testing. So another question for you, how many of you are every day writing unit tests?
What's a unit test?
Exactly. So this rant is for you. So testing in the broader sense, and unit tests in particular, generally speaking, people think unit testing is a good idea, but they don't put it in practice. And unit testing in Python is quite simple. You have the unit test package part of the standard library. Then you write your test, and then you quit complaining about the lack of time to write tests. And the last step is really optional, as long as you do step 1 and step 2. To answer your question, unit test is a test that you write a test for the smallest component. So you test the smallest assumption, and you want to validate the smallest assumption. So the benefits of unit testing, basically you create a safety net, because every time you touch something in your code, you're risking big problems, basically. You're going to break something else. You touch something, you break something else. And your unit tests, if you write a decent set of tests, are protecting you from this kind of mistakes. And it's particularly useful to have a good set of tests, say on a Friday afternoon, when you need to touch something and you don't want to stay late in the office. We can look at unit tests then as a way to validate your assumptions. You have your code, your functions, so you think in terms of input and expected output. Right? So you validate your assumption, data types, and so on. And you can look at unit tests also as a way to communicate your intention. So if your piece of code is a black box, input and output, you write down your expectations in terms of unit tests. Unit tests are also useful in terms of software design. So if something is difficult to test, probably you can refactor it and make it cleaner. So that's what I mean when I say you're forced to think. So you're forced to think about what you expect, input and output again. If you are on the academic side and you say, I don't write production code, so I don't really need to write any unit test. Say you're writing a paper, you write your analysis, and you end up with some numbers. These are taken from a real paper. Do you see the problem? Precision and recall, common in machine learning, and then you calculate the F-score, which is the harmonic mean of precision and recall. So you expect the number to be in between precision and recall, so this is out of bound. And I've seen this in a paper published in a A+ conference. So how can we work around this problem if we are in the process of writing some analysis and we need to test our numbers? It's really one line of Python. So you calculate your F-score, your precision and recall somewhere, then you sort out which one is the lower bound and the upper bound, and then the third line here is an assertion where you validate your assumption. So the assumption here is that the F-score is somewhere in between the other two numbers. So the unit test is just testing the smallest of the assumption. We don't know if the precision and recall values are correct. We don't know if the F-score is correct. We just want to check whether the F-score is between precision and recall. If you've never seen a unit test before, this piece of code alone is not a unit test. You still need to write the boilerplate code, so a test case, class, and your function. But that's pretty much it in terms of logic. Also, you should use the assertion from the unit test package that I mentioned earlier, but it looks pretty much like a unit test. So the message here is writing a single unit test is really simple. You test a simple assumption, and you want to test the smallest possible unit. You don't want to have the bigger picture in a unit test. Okay. So I'm nearly done with the discussion on the unit test. Some suggestions if you're just starting with unit testing. So the approach of slotting some assertion in your code rather than writing the unit test is called sometimes defensive programming. I'm not particularly a great fan of defensive programming, but if you don't need to write production code, so you just write a script and you're the only user of that script, that's one way to do it. So you don't need the unit test package. You just put assertions here and there, and if the condition is not valid, the assertion will blow up and raise an assertion error. So it's one way to check that your assumptions are correct. I prefer unit testing coming from a product-oriented point of view, but defensive programming is also one option. If you put some effort in writing tests, you should avoid a couple of things, in particular tautologies. So tautologies is when you repeat yourself. So you write something that doesn't add any extra value. For example, if you write your logic in the unit test and the test is wrong, you don't know if the bug is in the test or in the original function. So you should really treat your code as a black box, input, output, expectation, nothing more. You shouldn't write any logic in the unit test. And then vanity testing is what happens when you start buying into unit tests. You think it's a good idea, you like it, you start writing unit tests for everything, and you don't add any value, right? So unit tests should be useful, should tell you something. You shouldn't just write tests for the sake of it. In particular, there's a concept of coverage, which is the proportion of lines that are touched by any unit test. You shouldn't use coverage to say, look, I have a high coverage, so my unit test is, my code is well tested. You should kind of think the other way around. Use coverage tools to highlight which portion of the code is not tested yet. And this discussion about coverage also goes into knowing the ecosystem. So we have unit tests as part of the standard library, and then we have a whole bunch of useful libraries for testing. We have PyTest and Nose that kind of collect your test and allow you to run tests in different way. We have coverage.py for the coverage. You also have a nice GUI that highlights what you have tested and what you haven't. You know, green line has been tested, red line it hasn't. And then we have Hypothesis, which is a library to define strategies for your tests, so you can really kind of brute force your unit tests. You define what kind of input you want, and then the library will produce any sort of random rubbish that could potentially go through your function, and it will help you to highlight the edge cases that you didn't think about. Okay, so I ran out of quota in terms of ranting, and I carry on with the workflow managers that I mentioned earlier. So I want to introduce Luigi. Luigi is a Python library. It belongs to the family of workflow managers. If you are familiar with Unix, you can think of it as makefiles plus Unix pipes plus something else. In terms of features, what you do with Luigi, you define the dependencies between your tasks. So you have a pipeline made by many components. Each component depends on something else, and you can define this in Luigi by writing very little Python code, and you have some sort of error control and failure recovery out of the box. One nice feature also of Luigi is the visualization of this dependency graph. One of the key concepts in Luigi is the task. So a Luigi task is just a task, nothing more, a unit of execution. And what you see here is all the code you need to write in order to define your task. So you define your task as a class, which extends the Luigi task, and then you need to define 3 methods. First one requires, you just write down the list of dependencies, so what this task is depending on. Then you define your output. This will be maybe a file or a piece of data in the database. And then finally, the business logic of your task is defined in the run method. If you broke down the pipeline into packages, and you have your own libraries, so what you write here basically is just your library.run or your library.main, whatever you call it. So really, the extra code that you need to write to get the dependency controlled is really small. Another core concept of Luigi is the target, which is the output of a task. A target either exists or not. So the only function that you need to define here is exists, and it will return a true or false. Nice thing about Luigi and the kind of the ecosystem, the community, is that people have written already a lot of targets for many different types of data. So Amazon S3, Elasticsearch, many database systems. You can find everything in the Luigi contrib package. So this is coming kind of out of the box. If you have a new exotic database system that has not Luigi support yet, you just need to write that kind of class. So I mentioned Luigi because I had some positive experience with Luigi, but I'm not trying to sell you Luigi. What I'm trying to sell you is the concept of workflow managers. And there are many options today, in particular Airflow, Mr. Job, and Pinball. These are all Python-based libraries. So when I chose Luigi, at the time, all these were far behind in terms of feature, in terms of community support. So Luigi was a bit more mature, a bit more complete. I think nowadays they're pretty much on the same level. What I like about Luigi is that the extra effort in terms of Python code that you need is really minimal. Okay. Another concept that is often neglected when we write academic code that has to go in production is the concept of logging. A few weeks back, there was Alex Martelli giving a keynote at PyCon Italy, and he said the logging library is something that scares people off because it's so rich. The problem here is yeah, it's true that you can do a lot of stuff with logging, but you can start with the basics, really, so it's not difficult to start with. So import login, part of the standard library again. Why is it better than just printing for debugging? Because you can customize everything. So you can customize your log format, and you have extensive information already available in the login. For example, what kind of which line is causing the problem, what kind of severity you want to highlight. So you want info, you want debug, you want errors, different levels of information that you want to log. And once you slot your login functions in your code, it's very easy to switch it off, and it's very easy to decide what you want to see and what you want to hide. On the other side, if you go through the classic print function for debugging, then you have to go back and either remove it or touch your code again and again. Instead, login is kind of a production ready. And then you can decide whether you want to see your logs on the screen, or you want to save it on some file, and so on. So login, you run your pipeline overnight, go to the office in the morning. First thing you do is not reading the logs. Right? So you need some sort of a mechanism, some sort of trigger that will tell you if something goes wrong. In particular, with Luigi, you have an email notification system already out of the box. So you can get an email with the last traceback if you have an exception happening in your code. Or you can also use one of the many integrations. In particular, I'm working on this Luigi Slack integration. There's a work in progress that is basically pushing a message on your Slack channel or on a private, as a private message. And you can get some sort of report about the pipeline execution. Now, in summary, the starting point was R&D is not engineering, and the question is, can we meet halfway? My answer is yes. Usually, I don't like when companies build a huge wall between the R&D team and the production engineering team. I prefer to kind of sit in the middle and bring the two teams together. And one way to do that is learning some basic engineering principles. I mentioned testing, I mentioned logging, I mentioned the way of packaging and refactoring things. And these are really basics that you can benefit from, even if you stay on the academic side. So even if you don't have to go to production, if you think in terms of production, still you can benefit from it, and your code overall will improve and will give you better chances of working on what you like, basically. So you spend less time debugging, more time doing analysis. I mentioned replicability as something important in science, and of course in engineering as well. Automation. Everything that can be automated probably should be automated, because otherwise you get bored. And when you get bored is when you make mistakes. Right? So using the tools out there that are already well prepared and feature rich, for example, Luigi, but any of the workflow manager is going to be helpful. And before closing, I just want to mention the slides on the speaker deck. The Luigi Slack component is in my GitHub, and I'll write everything also on the Slack channel. Also, I'm fairly easy to find, and if you want to reach out, that's quite easy. I think that's all for me. Any question? Thank you. Question here?
Yeah, I kind of expect the answer, but I'm interested in motivations. So the rant against print didn't change with Python 3, allowing you to...
Sorry, I didn't get that.
Your slide against using print is valid also in Python 3, where you can rely on logging for print, for instance. Can you repeat the question?
Yes, the question is about not using print and using the login package. I use login in Python 3. I use nearly, for every project, only Python 3. The point is print is much less flexible than logging.
But you can redefine it in Python 3.
why would you want to redefine it if it's already there? So the login is much more flexible in terms of changing the configuration after you slot in all your login information. With print, you don't have the same kind of flexibility. So I write my login once, and then I only change one line at the beginning of the file to change the configuration. That's all you need to do. If you want to switch it off, redirect somewhere, change the severity, and so on. So print is not flexible. That's the short answer.
Our research guys use Jupyter notebooks.
Yeah.
How do you unit test Jupyter notebooks?
Yeah, that's not easy. You can use assertions. So it depends on what you do with your so Jupyter notebooks.
The fire alarm system is operating in City Gate House. Do not use the links between these buildings until further notice.
Okay. Okay, we're not using the lift. So
the fire alarm system is operating in City Gate House.
Yeah. Yeah, the suggestion it depends on what you're using your notebooks for, and probably defensive programming in this case is more useful. So you slot in assertions rather than writing the proper unit test here. And then as you execute your notebook, if something is wrong, you will see errors.
That's not a bad idea. So the problem is that they write it in the notebook, and then you have to move that into production.
Okay.
It gets too complicated for an engineer to test. But if they can do the assertions, you can take those assertions and then make a unit test afterwards, I suppose.
Assertions, yeah, you test a particular condition. So an engineer can easily read an assertion and translate it into a unit test. Usually you don't write assertions as I did in production code because, first of all, if you run Python in non-debug mode, which is what you should do in production, assertions are silenced. And secondly, because you don't want your code to just blow randomly in production, you want to test it on the side. So I think defensive programming has a place in the ecosystem. I don't particularly like it when I build products, but I think in notebooks it makes sense in general. Yeah. Yes?
Regarding Luigi, is there different experience with speed and volume of data passing through, or can you scale it up, run it on different machines using Unix pipelines?
So in terms of scalability of Luigi, they recommend to use it up to maybe tens of thousands of jobs per day, no more. It's oriented to batch processing. So if you need something more real-time and in the millions of jobs kind of scale, probably you should look into something like Salary, and you're going to be a lot more involved on the DevOps side. So Salary, just to mention, is a job queue, basically. So you need some sort of backend, some sort of message broker, and that, it's beyond R&D usually. There's a lot of DevOps involved. So I guess tens of thousands of jobs is still fine. You can specify how many workers you want in a single machine.
But it's pure Python based. It's not optimized with C code underlying.
It's pure Python. What you run doesn't have to be Python. So you can call something external, and Luigi will just be the glue around your pipeline.
Do you happen to know how the dependency sort of tree works in Luigi? Is it the task of polling, the outputs regularly, or
Okay.
is the tree built and then?
So how does the dependency tree work? So it's a DAG, directly graph. You define it in your code when you write your tasks, and Luigi will read your code. When you run Luigi, you're saying, I want this task to be run, so the end of the pipeline, and then Luigi will kind of read the DAG backwards, and we'll try to see what kind of task you've run already and what you didn't. And it's static. Okay, so you define your graph at the beginning, and then you run Luigi. You don't have a dynamic aspect of it. So that's, again, Salary is probably a better tool for this job. If you have new jobs coming dynamically and you want to throw them in your pipeline, So yeah, with Luigi you define a DAG, and with most of workflow managers that I mentioned, you just define your DAG at the beginning.
Cool, thanks.
Yeah, in the back.
So when you test the entire data pipeline, would you recommend having a sort of test Luigi instance and then also production Luigi workflow manager?
So end-to-end testing.
Yeah.
So end-to-end testing, you need to do something, right? So you should test your components in isolation. So run your component with real data in isolation. So I'm not talking unit test. I'm talking end-to-end test for the individual component. And then you can either test your end-to-end pipeline with Luigi or kind of triggering the individual tasks manually. I think it doesn't really matter as long as you do something about it. You don't have to kind of test Luigi. You have to run Luigi and test your code. So there's a subtle difference here. So test your expectations with Luigi, but don't test Luigi per se. Yeah, one more in the back.
Does the workflow managers you listed support multiple languages, or it's only for Python?
So the one workflow managers support in terms of other languages. The ones I mentioned are pure Python, but you can call external tools. So you can have, say, a Java or Scala application, and you can call the JVM from Python. Or you can call any Unix command line kind of tool or whatever you like. So the Python code that you write is just a definition of your pipeline and how the individual components work, or if there is a database in the middle or Elasticsearch or whatever, that's fine from the Luigi's point of view and also from the other workflow managers. It's kind of like I'm writing make files in some sort of sense. Yes?
Does Luigi have sort of scheduling, and is it a long-running process, or you just run it once?
So the question is whether you can trigger the pipeline from Luigi. Short answer, no. And the question kind of comes up more and more, so probably it's not so obvious. When I first was looking into Luigi, for me it was quite clear the separation of defining the pipeline, that is what you do in Luigi, and running the pipeline. And I've seen this explained as maybe a shortcoming of Luigi. What you have to do is you have three options. Either you run the pipeline manually, or you use a cron job to schedule the pipeline, or you integrate your pipeline with, say, Jenkins or any other CI tool. So in this way, you can also inject some environment information into the pipeline. So no, there is no mechanism built in Luigi to run the pipeline with some sort of cron or so you need to use external tools. Yes?
Got an example of what you've used Luigi for the audience?
Yes.
Context, please.
Yes, everything. So real-life examples of Luigi. I'm working mainly in NLP. So in NLP, you have more or less a bunch of pre-processing steps that you always want to do, or at least you want to try. So tokenization, stemming, stop or removal, the entity extraction, the usual things. Right. And sometimes you don't know which one works best for your data set, and that's one of the examples. Another example is right now I'm working in recruitment data, so matching candidate profiles with job specification with some machine learning. And then we have data cleaning, duplicate profiles, profiles that are not really well defined, so we want to augment with additional labels. And all these steps are applied to different data sets. So we have a few steps in parallel, and then we kind of merge everything. And it's, naturally it looks like a DAG, so we define it with Luigi. It's quite straightforward. But really, because the extra code that you need to write with Luigi is so small, it makes sense to use it every time you need to do some pre-processing step.
Thank you.
One here.
Someone asked about the maximum size of data that tools like Luigi could handle. I have the opposite question. When do you recommend using Luigi? So for instance, I work in academic research, so with like dozens of gigabytes of data, and I use Makefile. I have my directed graph in Makefile, and it's extremely fast because of unique pipes and unique tools, and I don't really want to switch to a few hundred or 1,000 lines of Python code to handle this.
Yeah, so the question is about the entry barrier to Luigi. I think personally I'm very comfortable with Unix, so I like Makefiles and all the weird things. But I've spoken to people in biology, chemistry, so they are domain expert in whatever they are studying, but they are not software engineers, so they don't want to bother. And Luigi is nice because you don't write that much code. So the concept is quite simple. You write a DAG, and the extra code is Python, so probably you are already familiar with Python. And there's really not much work to do. If your pipeline is 2 steps, maybe you don't need a workflow manager, but from 3 steps up, maybe it's nice. And you have a bunch of features out of the box, like error control and rerunning the pipeline. If something breaks halfway through, you rerun it not from the beginning, but from the last point of failure. So I definitely recommend a workflow manager in general. And as I said, I mentioned Luigi because I'm happy with Luigi.
Very last question.
From the back, yeah?
Do you think Luigi is suitable to embed in a desktop application?
Suitable to?
Embed or to make it part of a desktop application?
It's oriented to batch processing, so it really depends. If batch processing is what you need, then you can use Luigi. If you need something more real-time, then workflow managers in general are not what you need. You probably need to be a bit more involved on the message passing around. So that's my short answer on that, yeah. I think we ran out of time. I can take the next few questions during the coffee break. Yeah.
You're around all weekend.
I'm here all weekend, and you can find me at the meetup as well. Thank you.